So I'm Andy Voltmer, or Andrew Voltmer. I'm the IPv6 product manager at Infoblox, one of the sponsors here for gogoNET Live 2, and I'm here to talk to you about our product and how it integrates. Whoops. Basically, a quick agenda here. We're going to go over a brief introduction of the company and who we are, because we're not quite the size of a Juniper or Cisco. You might not know who we are. And then I'm going to talk about the feature set that we have in our product in the area of IP address management, and then some discussion about DNS and DHCP. So for those of you who don't know, Infoblox is a company that does products in the area of DDI, which is a Gartner term for DNS, DHCP, and IPAM. So we are a DNS server, a DHCP server, and we also do IP address management. So we are one of the few vendors in the space that really has significant market share. We're actually the market leader with over 4,700 customers and 40,000 appliances shipped worldwide, delivering DNS and DHCP services. Most of the market analysts view us as the market leader, both in market share as well as technology. So I won't go into more detail about that. I just want to make sure you guys know who we were. This is the obligatory customer slide. We have quite a large customer base, usually in the larger enterprise customer space, and also some service provider market. So we also have partnerships with some of the people, for example, Juniper, also Riverbed, F5, other technology vendors, and specifically in the IPv6 area. So that's really important, and I'll get to that in a bit. So let's talk about what is Infoblox. Well, so we do DNS, DHCP, and IP address management. These are screenshots of our UI. It's kind of hard to see for you guys, but effectively we're trying to make management of IP address space easier for the end user, and that's not just v4 but v6. So allocation of address space, blocks, control of what's allocated where, as well as provisioning of those systems, and then the delivery of DHCP and DNS to the client, both on the v6 and the v4 side. One of the key differentiators of our product is something we call the grid, and this is a single point of management UI to all of the appliances that deliver these services. So the customer can have up to 250 appliances worldwide in their environment, all doing DNS, DHCP, and it's all managed under one central UI. So that's really important when you're doing IP address management. You get a single rolled up view of everything in your IP address space on both v4 and v6 side. So another thing I want to mention is we have something called the Infoblox IPv6 Center of Excellence, and this is led up by Cricket Liu, who is works for Infoblox, and he's also a known author of the DNS and Bind book from O'Reilly. So you guys are privileged. You actually, I believe there are at least 2 O'Reilly authors in the room, Cricket and Sylvia. Are there any others? Oh, that'd be really impressive. But yeah, so Cricket's leading up that team for Infoblox. So key features, we support the ability to add IPv6 networks and metadata associated with those networks in our product, and then be able to search and configure on that. We have support for IPv6 on the DNS side, including reverse mapping zones and for IPv6 Quad A records. We support DHCP v6 for dynamically assigning IPv6 addresses. And we have support for a feature called DNS 6.4, which does translation between v4 and v6. So I'll go into each of these in more detail. So I'm not going to read this slide because it's sort of ridiculous, but this is a summary of all the different feature set we have and in the IPv6 area. And I believe the slides and the videos will be available to everybody. So later, if you're interested in seeing where we play in the v6 space, here is a sort of a summary of all the feature set. It's our general goal at Infoblox to be protocol, basically have protocol equivalence between the v4 and the v6 side, so that everything in our product that's v4 will also have a v6 feature associated with it. In some cases, the protocols differ. So let's talk about IPv6 networks. In our product, you can define a network or a container, which is really a network block, a v6 one, and then you can add metadata to it, like where it's located, or which city, which state, which rack, which row. So you can keep track of all this information associated with that IPv6 network. And we automatically containerize these things, so you'll see that up there you have some /50s. If you were to drill down into those 50s, you know, it shows you /52, /64s, whatnot. So it's all a graphical user interface for controlling that IP address space. So it's very useful for planning and allocation of address space. Here we have something called dual stack host records. So in our product, you can define a host object, and a host object is basically something that gets put into DNS. So a server, www.infoblox.com, and you can actually give it an IPv4 address as well as an IPv6 address. So you can manage that dual stack device and keep track of the correlation between the protocols. We have a dual stack appliance. We've had it for quite some time. You can have both a v4 address on it as well as a v6 address, and we have automatic router discovery, so we can set our gateway dynamically based on router advertisements, which is sort of pretty much a standard requirement in the v6 world these days. Here's a hard to read, but you know, an example of showing the interfaces and seeing what addresses are assigned to them and the auto-discovered v6 router. Here we're doing some queries over v6. So I'm doing a dig which against this IPv6 name server for www.bloxdemo.com, and I'm asking for a quad A record, and we'd return it below. So I'm going to go pretty quick through these slides because I have a lot of slides, and I want to make sure you guys get a chance to see all the different features we have. Sorry, let me go back a second. So we recently introduced a new feature called DNS 6.4, and this is something that the previous presenter, Olivier, I think mentioned a bit. So what this is the ability to automatically synthesize quad A records where they don't exist so that a client that is v6 only can get to a v4 resource via a NAT 6.4 device. So in the carrier ISP mobile space, this is particularly important because they're out of addresses, and they can't get more address space for a new mobile deployment. So we have a bunch of large carrier providers saying, hey, we're going to deploy handsets. LTE is a big case for this, and we need to give those handsets IP addresses. So the key here is, how do we get the address to the handset? Well, we have to give it a v6 address. How do those handsets get to v4 assets? They need to do DNS 6.4 and NAT 6.4 to convert back to the IPv4 space. In enterprise IT, there's not as much demand for this feature, but in the future we think it's going to be fairly significant because over time, as companies gradually turn off v4, this might be years away, but when they do, they'll still have legacy systems that are v4 only, and they'll create what I call islands of legacy v4 gear, and they'll likely put some kind of NAT 6.4 device in front of those islands so that those old assets can still be accessed by v6 only clients. So we're seeing eventual demand in the enterprise space, but immediate demand today in the mobile carrier space. So let's go over how this all works. I'll try to do this quick. So basically there's a client. It does a query to a IPv4 and IPv6 enabled name server. The name server in this case is an Infoblox box, but it's trying to find v4only.com quad A. The recursive name server then does a lookup to the actual name server of the end target device or destination and finds out that there's no quad A record there. It basically then has to do a second lookup to find an A record, and it synthesizes a response with a special /96 prefix, which is in the RFC, back to the client. So the client thinks it got a quad A record that really exists, but in reality there isn't one. The owner of v4 only doesn't have v6 enabled, doesn't have a quad A record. So then the client sends the packet to that destination, which is actually in the routing infrastructure as going to the NAT 6.4 device. So over here is some kind of protocol translator, either a Juniper or a A10 or potentially an F5. That's something that Infoblox doesn't do. So we do the DNS half of this. And then the translation happens off to the actual v4 side of it, to the destination server. The return path comes back to the NAT 6.4 box and gets converted back to v6 and back to the client. So that way the client doesn't have any idea that they actually queried a v4 only resource. Effectively to them, it's a v6 resource because they don't know that it went through the translator if all things work correctly. So the way this looks in our UI is you define what are called synthesis groups, and they basically, you can have one or more in case you want to route to different destinations. Some of the mobile providers will have different POPs or gateways with different NAT boxes. It's a very easy to configure in the product. There's a checkbox. You just check the box and it starts synthesizing Quad A records. So very simple and straightforward to get deployed. So far we've done integration testing with F5 on their NAT 6.4 box with version 11, and with A10, who's also a sponsor, and we tested with their version 2.6.4. So Infoblox actually did the QA work to make sure this all works end-to-end. For the Juniper guys in the room, we'd like to do it with you. Whenever you're ready, we're ready. So our goal was to be interact properly with other devices on the market. So let's talk about DHCP v6. We recently implemented DHCP v6 in our product. We've had DHCP v4 for 15 years or something along those lines. And there are different use cases for DHCP v6. There's the stateless deployments in which the client auto-configures an address. And then there are stateful deployments, which most customers of ours are used to on the v4 side, where the DHCP server hands out an address. So it's much like v4 today. So a lot of our demand was for actually for stateful. We have a lot of enterprise customers who are used to stateful and comfortable with it and want to continue to control the address allocation. Now, in general, there seems to be a holy war between stateful and stateless in the v6 world. But again, a lot of our customers are comfortable with the v4 world, so they like the idea of doing a stateful deployment. So effectively, we can hand out IP addresses from a DHCP server on the v6 side, and we can also do prefix delegation, which is entire blocks of address space to a downstream device that then will further lease that out. So let's talk about stateful versus stateless. You know, it's all driven by the router in the router advertisement, whether or not there's an M, an O, and an A flag set. So depending on that, it will provide you with either a stateful or stateless setup for the client. Again, a lot of our customers are looking at doing the managed option, which is effectively let the DHCP server hand out the address. So I won't go into too much detail. I assume a lot of you guys know what's going on in this world because you're sort of the v6 leading edge experts. A lot of our customers don't know. They don't know what an M and an O bit are. So we usually provide them with a lot of information in these types of slides. But again, M is managed so that the client knows to get its address from DHCP v6, and O is for all the options that the client will get from the v6 server. So an example on a Cisco router, how to set these flags. You set the M bit, the IPv6 ND managed config flag, and the O bit is the other config flag. A couple of people have pointed out to me this isn't all exactly correct. This is what I had to do on my particular version of iOS, on my lab to make it work. In some other versions of iOS, I believe you only have to set the managed bit to make it fully managed, that you don't have to set the O bit specifically on the router. So here's an example of a stateful with Infoblox where we will provide, the router provides the router advertisement, we provide the address and the options, but we also support for those who want stateless mode. If the client wants to just get options from us, the router can provide the router address, and then the client self-configures or uses Slack to get its self-provisioned IP address. So on the feature set, the product has, we support v6 networks, ranges, fixed addresses, which is where you have a fixed DUID associated with an IP address. We support templating of these things. We support, like I mentioned, dual stack host objects, which are devices that have both a v4 and v6 address. We support what we call extensible attributes or metadata on all sorts of v6 objects, so you can quickly filter and find objects within the environment. Our API fully supports all this functionality, and we have lease viewers and lease history so that you can view what's going on in terms of who has what address and when they received it. So here's an example of defining a network. You can see I made this one in my lab, FC001010 413A, and it's a 64. And within it, I set up some ranges, including a prefix delegated range, as well as a range for clients and a fixed address. And here we try to make the user's life a little easier by providing them with a net mask slider, which will calculate how many /64s are available under a container or how many addresses are available. We also have something called a IPv6 prefix. We provide a shorthand mechanism so that the customer doesn't have to keep remembering their v6 prefix from their ISP. They can just name it in a drop-down. If they choose it, it'll auto-populate the field for them with whatever their prefix is. That one's pretty easy to remember, but most ISPs are going to give the customer something that's not so easy to remember. So we're trying to add naming to these actual address space instead of having to remember all these complex addresses. So here are some examples of that global prefix. They can define a couple different prefixes in their environment and then have a drop-down to help them remember which prefix is from provider A, provider B, or provider C, or wherever the address space has been allocated from. Prefix delegation, I mentioned this before briefly, but this is something where you can actually hand out entire address space to a downstream device like a home gateway or router, and then that router can then hand it out again. And my analogy is, in a normal lease, you're leasing an apartment. It's like leasing an apartment from a landlord. In this case, the client is leasing an entire apartment building and then turning around and individually subletting the individual apartments. So this is prefix delegation. You're effectively handing out a lease for an entire prefix and then letting that downstream device be the new landlord for that specific space. So we support this functionality. Nobody's using it that I know of yet, but we do support it. Here's a lease viewer where you can see the address, and you'll see some v4 addresses, but you'll see a v6 address, and you see that it is mapped to a DUID from the client, and that a client got it. This actually happens to be the same client. It got a v4, his name is Morrison, and it got a v6 address. So you can kind of in our UI see that that is actually the same host, one on the v4 side and the v6 side. So some resources for people. I don't think everybody in this room really needs it, but I'd really encourage you guys to, if you haven't already done so, get a tunnel set up with Hurricane Electric or somebody like that to your home, or if you can get native IPv6 to your home, that'd be great. We have about 120 SEs worldwide, and most of them have set up a tunnel and have had really good experience doing so. And a few of them actually have native IPv6, mostly in Europe. I don't know of anybody in North America who has straight IPv6 to their homes yet. But I do find it interesting that we were able to get about 120 people up on the v6 networks in general using Hurricane Electric and their certification. So I don't know if Owen is here, but credit to the guys at HE for the stuff they've been doing. So that is it. I will be around for questions later if you have any. I don't think we have time right now to do questions. So thank you for your time, and thanks for the event for allowing Infoblox to do our vendor pitch.